Hey guys, this is TKA AMC Meeting to November 18th, 2020. And this is a virtual meeting. I'm recording this video because of some special circumstances today. But this is not going to be a usual thing because we are having meeting in person every Wednesday. So, and I will post the answer in a document on the Moodle and remind. And this video will be posted on Moodle too. And let's start it. This is a session A, means we're going to learn something new today. So get a scratch paper, pencil with a notebook, and we're going to jump into the first theorem right away. So the remainder theorem is if a polynomial px is divided by a linear factor x minus c, then the remainder is pc. So I have to know the remainder, the concept of remainder. We know when x divided by y equal to, let's say, p, if the remainder is a, what does it mean? That means without this remainder, x divided minus a, then you divide by y again, it can be divided completely, right? So it's gonna just become p. Or you can write as, x minus a equal py, or x equal py plus a. And how does that apply to this? We know a polynomial px divided by x minus c, it will become a number, something or whatever others, it will become another polynomial. Let's say kx, and the remainder is pc. And what does it mean? Is px minus pc over x minus c will equal to kx, So this is something they have to know how to transition, the transition between these equations. So let's look at the first question exercise. Let's try this question, and you're gonna pause the video and do it yourself for about, I would say, 5 minutes, and then we'll look at we'll go through the solution together. Okay, find the remainder when x plus 2 is divided into the polynomial px. So this is straight applying the concept. We know the remainder is going to be what? P negative 2, because c is negative 2. Remember, the original concept is x minus c. So when we plug in negative 2 into the into this polynomial, we'll get negative 69, and you can calculate yourself. And next, we're looking at 1999. This is the previous name for AMC. And pause the video again, and it will spend about, let's say, 10 minutes to do this question. Okay, let px be the polynomial such that when px is divided by x minus 19, the remainder is 99. And when px is divided by x minus 99, the remainder is 19. What's the remainder when px is divided by x minus 19 times x minus 19i? And this will seem like very confusing in the beginning, because it kind of, very close to the concept, but it's also very different because you're having a non-direct linear equation as a divider. So you couldn't definitely not use applying the concept directly. So what we will do when we're confusing is we just map out what we have. Okay. So what they are asking? They are asking the remainder of the when the px divided by this, right? So we rewrite that as the form we previous talking the form we previous talked about is px divided by minus remainder, right, over divider, which is x minus 19 times x minus 99 will equal to some other equation, polynomial. Okay, and this is what we got. And we also know that, you know, since when it's divided by this, which is a linear equation, it will go to the remainder 99, which means applying the concept P19 equal to 99, right? We also know when Px divided by x minus 99, the remainder is 19, which means P99 equal to 19. So that's what we have. So my instinct solution is to try to make x equal either 19 or 99, right? So let's pick 99. So what we'll see is the remainder here is x minus 19 times x minus 99. So if we just plug in x equal 99 here, it's going to be a 0. It won't work, right? But what we can do is we put this part, the x minus 99, over to another side. So we just times that to another side, which will give us this equation. So after we get this, we plug in 99 to the x, we'll get P99 minus r equal, which is 99 minus 19 is 80, equal 0 times kx, which gives you whole thing as a 0. Okay, and you can simplify this by just times the 80 there. So the whole thing will be P99 equal r. So when we got here, what we see is we got a P99. We got a remainder when x equal 99, right? So we know P99 is 19. So we know when x equal 99, the remainder is 19. Okay, what we have here is this 4 solution. I mean the 4 answers. Can it be 0? No, it can't, because we already know the remainder is 19. If it's 0, it will be constantly 0, right? It had to be something about x. So can it be a positive x? No, because we plug in the positive 99 and it gets us 19, which makes it smaller. So definitely it's not positive, because another constant is positive. It would only make it larger. So it can be either A or C. So we cross off those that doesn't apply. So we know it's a negative x plus a constant k, and that equals 19 when x is 99. So we just plug that in, and what we got is 118. So the correct answer is C. So there is another solution that the book provide, and I do it myself, so I use my solution, and I will post the book solution in the PDF. I'm gonna send you to through the Moodle and remind. Okay, so next go to the next theorem. Factor theorem. C is the root of polynomial Px, that is Pc equals 0, if and only if x minus c is a factor of Px. To understand this theorem, we'll have to understand the meaning of if and only if. If and only if means double implies A, double implies B, means if B is true, then A is true, and if A is true, then B is true. So how does it imply to this one? That means if C is the root of Px, then we can say x minus c is a factor of Px. And if x minus c is a factor of Px, we can say c is the root of a polynomial Px. This is simply an extension of the last theorem, because when c is root of Px, we know that when Px divided by xc, according to the concept, the remainder will be Pc, and since Pc is equal to 0, that means Px can divide by x minus c completely. So that's how this theorem is derived. And now let's try a question. So pause it and do it yourself, spending about, I would say, 5 minutes, and then come back. Okay, suppose a, b, c are integers such that a is larger than 0 and b is larger than a. The polynomial x times x minus a times x minus b minus 17 is divisible by x minus c. What is a plus b and plus c? X minus c here we can see it's a factor of this polynomial. Okay, and how do we solve this? So we can apply a theorem. We know that if we plug in c into this, the whole thing is 0, because c is a root. According to the theorem, c is a root of this polynomial. So we know this Pc is going to be 0, which means c minus a, just plug c in, will be 0. Okay, and then we can move that 17 to another side, because that looks like a solvable problem. When we look at this problem, we really want to notice that they are all integers, and then a, b is positive, and 17 is a prime number. So when we see those stuff, we know we can just list out all the possibilities and solve it. We don't have to actually know everything. We don't have to know each of them. We can just list all the possibility and clear out. So since 17 is a prime number, so how this 3 integer, we know this 3 are integer because a, b, c are all integers, right? So how this 3 integer will be, they can only be a combination of 1, 1, 7, right? So can c be 1, 1, 1, 17? So can c be 1? It has to be, because if c is negative 1, while a and b is all positive, then these 2 are all negative, right? And c is negative 2. Therefore, the whole thing is negative, but 17 is positive, so c couldn't be negative 1. So c had to be positive 1, or had to be positive. So can c be 17? No, it can't, because we see a and b are not equal. So c minus a and c minus b are not equal. They couldn't all be 1, because that's only 2 left to pick, right? Or negative 1, negative 1. and it couldn't be positive or negative because that would make the whole thing negative. So it had to be 1. Have to be 1. So how about the second one? C minus A. Should that be 7? Should that be a 17, plus or minus 17, or plus or minus 1? We can see that A is a integer larger than 0. So the smallest A is 1, right? But there's no 0 here, so it had to be large. Had to be, the whole thing had to be smaller than 0 because A had to be larger than 1. So A could be 2, could be 3. So when A is 2, it's negative 1. If A is 2, it's negative 1. But can it be, can this be negative 7? No, because if we pick negative 17, negative 17, then B has to be this whole thing had to be negative 1, right? And when this whole thing is negative 1, B is larger than A, B is smaller than A because, you know, it gets smaller. The absolute value is smaller. So this C minus A have to be negative 1. So therefore we know this one had to be negative 17. So that the whole thing is 17, right? So when C minus B is 17, while C is 1, B has to be 18. Make the whole thing 17. So what's A plus B plus C? Is 1 plus 2 plus 18, which is 21. That's the correct answer. And that's all I have today. And don't forget the meeting on Friday. And we're gonna talk about something else. And if you have any questions about today's outside lecture, you can check another package or send out the PDF for all the answers, and you can ask the question personally on Friday's meeting. And I will see you guys next time.